This conference will now be recorded.
So in the demo session, we were looking at the end-to-end understanding of data science. Today, what we'll do is we'll try to look at the entire curriculum. We will see what are the different modules which will be used, what will be the things which will be covered throughout the course. We will also concentrate on what are the projects. So I said that this is a project-oriented learning. So we will see like what are the different projects which will be covered and how the entire course is structured. So I try to ensure that we try to have the course which covers the breadth and depth of the data science in a practical sense. So we will start with the very basics of understanding what is data science, what are the different things about data science. So the first one is the module 1, where we will discuss about the foundations of data science. We will see like the introduction of data science and high level overview. So this entire week we would be covering on these topics. We'll understand, we saw the end-to-end understanding of data science, but we'll also go to the subtle differences between data science, machine learning, AI, what are the different approaches of machine learning, what are the different terminologies used in data science and different applications of data science. All those things we would be looking in this particular module. So this will give us for everyone, I'm sure most of you guys have already gone through some videos or content somewhere else, which would have given you a basic idea of what this data science is. But in this content, what I'm trying to make sure is I am bringing everybody on the same page. So I will give my perspective of how data science is used, what are the applications which are used, what are the different approaches which are used, and so on, so that everybody gets a similar understanding. So everybody will be on the same page. So the first module will be talking about that. Once we complete that, we will get into mathematics for data science. Now, this is very important. Many people say that math is not required because I'm using some module, I'm using some function library. I could directly import the function or library and get my output. That is true to some extent, but it is not at all true when you look at this entire field, data science as a field, because there are a lot of internal things which are done in the data science, and if you do some little bit of tweaking and if you do some understanding of what is the mathematics behind these functions, it will give a great value for you. So we will cover some of the basic mathematical concepts: linear algebra, matrix operation, eigenvalues, eigenvectors. Why do we use all these things in the data science? So we will get those understanding. Now, I'm not going to talk about how do we do matrix multiplication, but we will be talking about why this mathematical concepts will be used for so and so things, like why do we use these scalars, why do we use vectors and tensors, where does the probability come into picture, why do we use calculus, differentiation, gradients and cost functions and all those things. What is the actual reason for using those things, and how do we implement them in the real world? Those are the things we would be covering in this particular session. So we have linear algebra, matrices, matrix operations, eigenvalues, eigenvectors, prior and posterior probabilities, conditional probabilities, and different other things will be discussed in this particular section. So module 2 would be covering completely about the mathematical concepts. And once we complete the module 2, we'll get into the statistics for data science. Now, statistics is also very important. So the first 1 month or 3 to 4 weeks or 1 month, we would be only covering about the basics. This entire course is for 3 months duration. So in the initial days, we'll only be covering on the basics. So everybody will get onto the same understanding level. And once we have a very strong foundational basics, we will get into the deeper concepts of machine learning, deep learning, natural language processing, and advanced analytical techniques. So we'll cover those things in the coming sessions. Now, statistics for data science is very important. There are two major sections of statistics. One is called as descriptive statistics, and the second one is called as inferential statistics. Now, the descriptive statistics talks about the data as in its current state. So imagine I already have a past information. Now, with the past information, I'm trying to explain what has already happened. So for the last 1 year, I have the information about the car sales, and I'm trying to explain like what happened in the last 1 year. So where was the car sales higher? Where was the dip? And how the recovery happened? See, all those things, if I'm trying to explain, that falls under something called as descriptive statistics. In the descriptive statistics, we will try to understand how the data looks like, what is discrete, what is continuous, what is nominal and ordinal data. We'll try to understand about the tendencies, especially the central tendency, which talks about where does the data lie, like what is the centrality of the data, where does the data is lying. For example, mean, median, and mode, these are some of the central tendencies. And machine learning, we will try to focus on the central tendencies because I'm trying to target the central observation. So if I'm trying to target like a dartboard, or trying to target this center 100 mark, you will try to achieve at least 100 or maybe 90 or 80 and so on. Even in the machine learning, we will try to focus on the central tendency. We'll try to focus on the mean and median values. So when you're predicting these mean and median values, you will almost achieve the good amount of accuracy. Similarly, we will learn about measures of dispersion, or we can also call it as measures of spread. Like that will explain like how much is the data spread, what are the parameters which will measure the spread of the data. For example, variance and standard deviation, these are some of the values which measure the spread of your data. We also have range, quartiles, interquartile ranges, different measures of shape like skewness and kurtosis, and tests of associations like correlation and regression, and different values like random values, probability distributions, different distribution functions will be learned here. So descriptive statistics is always talking about the data which is already completed. We already have some processing done. We have data which is already collected, and we are trying to explain what the data is. Next coming is the inferential statistics. In inferential statistics, what we'll discuss is this is about doing some predictions with already existing data. In most of the statistical terms, we try to have these samples, and based on the samples, we'll try to do some inferences. For example, you are doing an election and you're trying to do an inference like who is going to win. Now, what you do is you collect a sample of different people who are going to vote, and then trying to get the opinion polls of those people, and then trying to do the extrapolation of the results. Now, if you're collecting a right amount of sample, then your inferences will be correct. If you're collecting a wrong sample, the wrong distribution of a sample, your exit polls will be wrong. So in inferential statistics, what we do is we'll learn about what is statistical sampling, what is an inference, how do you conduct a hypothesis, what is called as hypothesis testing, what are different tests of hypothesis, for example, null and alternate hypothesis, what is the error, how is the margin of error identified, what are different types of errors like type 1, type 2 errors, how do you conduct a one-sided hypothesis, two-sided hypothesis, what are the different types of other tests like chi-square test, t-test, and analysis of variance, or also called as ANOVA. So likewise, there are different types of tests which will be conducted to understand how good my hypothesis is and how good my inference is. So this inferential statistics will help us to really get the predictions to a greater accuracy. So statistics will give us this basis of how do we use these descriptive and inferential statistics for doing predictions. And we will use these statistics throughout the machine learning exercise. Now, statistics is not a separate field. It's not like isolated. It is very interlinked with all the machine learning models. So whenever we go deeper into the machine learning models, we will again loop back through the statistical concepts. We'll see like, okay, what statistical concept is linked with the model, so that we can get a clear understanding of how these models are linked. Now, once we have a basis of mathematics and statistics, we'll get into the Python for data science. Now, people have this question that I do not know Python. I know like programming. I know some Java. I know C++. I have done my C# coding, but I have never done anything in Python. So for such kind of people, don't worry. What I expect from you guys is having some basic understanding of programming, because I would not be covering about what is a function, what is a loop, what is a variable, and so on, because that is a completely a very basic level. We will not be covering that, but we will be covering Python for data science, for writing data science programs. Right? Data science programs would require some important libraries. So we would be covering libraries like Numpy, Pandas, Matplotlib, Seaborn, Jupyter Notebook. So these are some of the libraries which are used in Python for constructing end-to-end data science projects. So we'll see how these libraries are used, where they are used, why they are used, and all those things we will discuss in great detail. First one is the Numpy. Numpy is called as the numerical Python package for library for Python, and it is used for doing numerical operations. So if at all we are doing some numerical number operations like summation, mean, average, we try to apply exponential, logarithmic, and other things, you would see that there are different types of numerical operations which are applied in machine learning. So for doing that, we would use NumPy. So here in this section, we would understand about how do you compare the NumPy with traditional lists, what are the different NumPy data types, how do you perform indexing and slicing, what are the different numerical operations you would perform using NumPy, different aggregation functions, shape manipulation functions, some statistical operations, and all those things you would cover in this section. Now, this would give us a very strong foundation on how to use NumPy for all the mathematical operations which can be performed using this library. Once you complete NumPy, you'll get into something called as Pandas. Now, Pandas is like a Swiss Army knife. This is like an all-purpose tool which will be used in data science. Now, Pandas, we are looking at how to load data using Pandas. This is more like a CSV file. If you have worked with Excel a lot, you will appreciate how Pandas would be used. For example, it could be used for selection, slicing, separating your columns, randomly selecting based on some condition, doing descriptive statistics, using joins, group by indexes, multi-level indexes, merging and concatenating your data frames. So all the work which we'll generally do with CSV files and tables, the SQL tables, all those things can be done with Pandas. Pandas is a very powerful tool, and we will use throughout the data science course. We will use Pandas and NumPy and Matplotlib. All these things will be used throughout this course. So to understand that, we will have a lot of examples. We will have a strong foundation in this particular section. And once we have completed this, we will get into the visualization part. Now, visualization is very important in data science because we need to understand how my data is related. What are the columns of my data, how they are related, is there any correlation in the data, and how each column is contributing to my output. So all these information we will not be able to make out with numbers. So if I give you an Excel sheet, it is very difficult for us to understand what are the patterns between my data. Now, my Excel sheet might have 1 million records, and it might have 50, 60 columns, and it is very difficult to correlate all these values and come up with some kind of understanding. Now, that understanding can only be solved by plotting some graphs, plotting some graphs in terms of relations between the variables and other things. So that could be done by. So is there a question?
Is the screen sharing? I'm not able to see the screen.
Yeah, screen is sharing. Not sure if you are able to. Can you log off and log back again?
Yeah.
Can others put it in the chat window if you guys are able to see the screen? I'm sure you are.
Yes, Sitaram, we're able to see.
Yeah. So sometimes if you have these kind of issues, right? So I would recommend to quickly log off and log back again. you will be able to resolve these. So what we are discussing is the importance of visualization. So visualization is very important because I want to understand from a pictorial representation how my data is related, and how is it related to my output. And if I know those informations, I will be able to easily create those identify the columns which are very important. I can identify the columns which are not at all helping me. So there will be some non-value added columns which are no longer related, and they're actually deviating my model's performance. So I could do all those kind of identifications. So for that, we will use two libraries, very commonly used libraries. They are called as matplotlib and seaborn. Now matplotlib is a basic library which will help us to do some basic graphs. Like we have histograms, scatter plots, you have basic plotting libraries. You could do something called as pair plots or scatter matrix. So some of the basic graphs can be plotted using your matplotlib library. And for some advanced graphs, like some more colorful and advanced graph, we will use the seaborn library. It could be used for plotting box plots, violin plots, cat plots, swarm plots, pair plots, LM plots. Likewise, different types of plots are there, and you could plot these different graphs of your data. And what this will do is this will help us to visualize my data, relation between data, and all the things. Now, once I get a comfortable understanding about what my data is talking about, I will be able to clearly pick and choose variables which are responsible for my output. So the ones which are very, very important, I can pick and choose those variables. And with that, I will get good amount of accuracy. Now, once we understand these basics of things, we will get into something called as exploratory data analysis. Now, this is a section where we'll be using all the libraries, whatever we have learned so far. We will use the Pandas, Numpy, Matplotlib, seaborn, all of them combined together. We will be doing the exploration of data. Exploration of data will help me to identify the patterns of the data, understand how these variables are related, what are the statistical relation and other things. Exploratory data analysis is also called as EDA. EDA is a shortcut, and it will divide into multiple sections. We will do like data acquisition, we will do the data preparation, like data cleaning, data visualization, plotting of the data, and then finally we would also do some of the data preparation techniques like selection or removal of the columns. We will do transformation, rescaling, standardization, normalization, different types of encoding techniques like label encoder, one-hot encoder, and imputing techniques like missing value imputations, dividing my data into training and testing. So all these things will be performed here. So once you collected the data, we'll try to apply all these techniques and then try to make the data in a much more consumable format. Once the data is in a much more consumable format, then your model will perform very well. The machine learning models will perform really well if the data is in a very consumable format. Now, what is consumable? Consumable is you try to identify the right patterns, you try to convert into right variables, you remove unwanted columns and do all that work. So your raw data will be converted into a consumable data. If you directly give the raw data, what happens is your model will try to learn from unwanted columns, and it can yield into some wrong results. So you don't want to get that. So bottom line, if you give garbage to the machine learning model, you will get garbage results. So what you have to do is you have to spend a good amount of time to clean the data, to create it in a nice format. Then you give it to the machine learning model, and it will give you the better results. So that is how the process would work. So till now, what we have learned is we understood some of the basics of these libraries. We understood what is mathematical concepts, what are the statistical concepts used, and with all these basics, we will get into the machine learning section. Now, by now, we almost might have completed 1 month of our training. So machine learning, we will start in the middle of our course, where we will understand what are the different machine learning techniques, different applications used in the machine learning, what are the subsections of machine learning, like supervised machine learning, unsupervised machine learning, reinforcement learning, and how do you do model representation and model evaluation? What are hyperparameter tunings? How do you evaluate the models? How do we create the models in the real world? What is the deployment strategy of these machine learning models? All those things we will learn in this section. So this is a section which is giving an kind of an introduction to the machine learning and understanding how these things are used in the real world. Once that is completed, we will go deeper into individual sections. The first section is supervised machine learning classification, where we understand about different classification techniques. Now, what is a classification? Classification means we will use the machine learning model to predict one or the other class. So I'm given two photographs of X-ray scans of a COVID patient. One is COVID positive and other one is COVID negative. So I'm looking at these X-ray scans or the CT scans, and then I'm trying to identify whether it is a positive or a negative case. Now, this one is an example of a classification technique. So we are trying to classify yes or a no, true or a false, spam, not spam, approved, rejected, withheld, denied. So if you are seeing, these are all our classes. If my output is a classification, or if my output belongs to one or the other class, then I call it as a classification technique. So supervised machine learning classification, the algorithms which are used are k-nearest neighbors, decision trees, naive-Bayes models, stochastic gradient descent, support vector machines, random forest, gradient boosting, logistic regression, XGBoost. So these are a few models. So we are already gone through like some 7-8 models, and we would also use some combination methods like combining these multiple models. There are different techniques like bagging, boosting, voting, combining multiple models, and so on. So combining all these things, you will get much more robust models. All these models will be used for classification techniques. Now we will also do something called as model tuning. Now that is used for creating better models. Now models can be tuned. The process is called as hyperparameter tuning, where we try to tune these models. So there are some code requirements which are to be done. So we can tune the models and try to look at different techniques like k-fold cross-validation, variance and bias trade-off, applying some different normalizations like L1 L2 norms, identifying how do you do overfitting, underfitting, and apply hyperparameter tuning using different models. Those all things will be done to see like how to improvise my machine learning models so that they can give you the best accuracy. So as you have seen, we have also looked at some of the performance metrics like accuracy, confusion metrics, precision, recall. These are some of the metrics which will tell like how good your model is. Like my model could be maybe 90% good, 80% good, but how good your model is, what is the good in model, what is bad in model. So you will be able to dissect all this information by performing these performance measures, and that will help you to understand the information about your model. Now don't get worried about looking at all these names. At this point it will be like completely overwhelming for you, but believe me, as we go through the course, we would be going at a very steady pace, and as we go through the course, you will be understanding each and every bit of what I'm talking, and definitely you will be appreciating how these models are created, how to improvise these models, which model to use at which situation, what type of data, which model to use for what type of data. All those things we will slowly understand. Once we complete the classification techniques, we will get into the regression models. Now, what is the regression models? Regression is basically predicting numbers as an output. Now, if I want to predict the number of car sales or the loan amount to be dispersed to an applicant. Now, the loan amount could be 110K, 115K, or 85K. So it could be anything. So the numbers, whatever we are predicting, that falls under something called as regression. Now, there are different models again in the regression. We have linear regression, the variants of regressions like lasso and ridge regression, multilinear regression, logistic regression comes under classification, but we have polynomial regression, random forest regression, support vector regression. Likewise, we have again some 5-6 models. Again, we will see under the regression category, we'll see like how to predict my number terms, my output of a company. I want to predict the profitability of a company, revenues of the cars, or stock market price. For example, Infosys is at say like 800 rupees right now. After 1 month, what will be the price of the company? Whether it will be 852 or 890 or whatever that price. So I'm trying to predict that number, and that will be called as a regression term. Right, so we have covered supervised classification and regression. Those are the two important areas. Once we complete the supervised machine learning, which is where I know like what is the output I'm predicting. Now classification will tell me the output class, whereas the regression will tell me the output amount which I'm trying to predict. Those are called as supervised classifications or regressions. Supervised means that I know like what is the output I'm going to predict. The next two techniques are called as unsupervised machine learning. Unsupervised machine learning falls under the category where I don't know what is the output, right? I don't know what is the output. I will just have some X values and I'll try to find out relation between the X values. Are they related? Can I group them together? Can I separate them? Is one value related to another value? Or is one value correlating to another value or contributing to another value? So all these things can be understood by unsupervised machine learning techniques. So they are popularly called as clustering techniques. Like we will use k-means clustering, hierarchical clustering, DB-scan, and other ones. And there are other models like association rule mining. So you might have heard that we would find out association between the products. Based on the associations, we could do a lot of things like predicting recommendations, combo offers, and so on. So all those things will be used in association rule mining. We could do something called as market basket analysis. We could also apply something called as dimensionality reduction by using principal component analysis, and so on. So these are all the things which will be used in the unsupervised machine learning. So once I complete unsupervised machine learning, we will get into natural language processing. Natural language processing is using textual data. So how do we use text data? So if at all it is a comment in Amazon, so how do I use it, make sense of it? If it is some text of a book, or is it some documents, like how do you make sense of that? How do you differentiate them? And playing with the natural language processing is what we will discuss here. The natural language processing, we will talk about text analytics, stemming, lemmatization, stop word removal. We will talk about parts of speech tagging, name entity recognition. How do you create matrices like term document matrix, count vectorizer, term frequency, and inverse document frequency. Likewise, we are dealing with different types of techniques which will be used for dealing natural language text. And how to use this natural language text to apply machine learning models. So those are the things we are targeting here. So once that is done, we will get into some advanced analytics. We will talk about time series forecasting. We will talk about ANIMA models, content-based recommender systems, collaborative filtering. So these are some of the little advanced techniques we will be using, and which will help us to understand even more better models. Once we complete unsupervised machine learning, natural language processing, and advanced models, we will understand about something called as reinforcement learning. Now, reinforcement learning will discuss about some of the basic concepts, like what is action, what is a reward, how to apply penalty mechanism, how does this feedback loop works in reinforcement learning. All those things we will be discussing in this section. So once we complete that, we will get into AI, artificial intelligence. Specifically, we'll be talking about deep learning, and I'll be talking about neural networks. We will talk about neural networks and the terminologies. How is the nonlinearity problem solved? What is a perceptron learning? What is a feed-forward network? What is a backpropagation? How do you apply gradient descent? And what are the mathematical concepts which are involved behind this gradient descent topics? Especially like the linear algebra, eigenvalues, eigenvectors, different projections. All those things will be understood here. We will also learn about what are the different tools which will be applied for these techniques. After that, we'll get into the deep learning models. Deep learning is a subsection of machine learning, especially using the artificial neural networks. We'll see like how these artificial neural networks are used in more elaborated manner. We will try to identify how to create the hypothesis functions, how to minimize the cost functions, how to relate it with the hidden Markov models, how to create output predictions with respect to deep learning models. How do you do optimizations of the deep learning models? And we will also discuss about different other techniques like convolutional neural networks, recurrent neural networks. Convolutional neural networks will be used for images and video analysis, like identification of images, characterizing the images, building a classifier models on images, and doing video analysis. All those things will be done by CNNs. Whereas RNNs, they are used for time series data, for example, chatbots or machine-to-machine translation, speech-to-text translation. So such kind of things could be used in recurrent neural networks. So we'll learn about how to do CNNs and RNNs. This will give us a good idea about deep learning models. Now, this will almost be at the end of the course, but we have two important subsections, cloud computing for data science and DevOps for data science. Now, without this, our entire course would be meaningless. So we have two important sections where we understand about how to deploy these models on cloud. I will be talking about AWS specifically, but this could be applicable for other clouds as well. Azure or Google Cloud. I have good expertise in AWS, so that's the reason I have picked up this topic. In this, we will understand about what is cloud computing, why do we use some of the different services of cloud computing, like S3, EC2, and RDS. How do you do big data processing on cloud? How do you machine learning processing on cloud? How do you apply deep learning, natural language processing on different cloud services? Some pre-built cloud services are there. So we'll also see how to use those pre-built cloud services for deploying end-to-end pipelines on machine learning on AWS cloud. This will give us a brief idea. This is not a course on AWS. Of course, it would cover like if I already have created a machine learning model, if I want to deploy it on the cloud, what do I do it? What do I do to deploy that model on the cloud? What are the important pieces of information which I need to know for deploying this model onto cloud? So going forward, we will not be having separate cloud developers. We will not be having separate DevOps persons or machine learning persons. We would be having only one single role who have to do all these things. And it will be a deadly combination if you have a expertise in cloud, DevOps, and data science, because going forward, everybody would be expecting these kind of skill sets. So that's the reason our course is geared towards giving that holistic knowledge so that everybody gets the good understanding of that. Once we complete the cloud computing, we'll get on to the DevOps part. Now, DevOps, if you're familiar with, is nothing but a process where we can automate a lot of internal tasks. So, for example, in infrastructure development, or it could be automating some of the jobs, some of the tasks, and some of the activities within the project. All those things can be automated so that less manual intervention is used, and you would also avoid the errors which are caused by human intervention. So the DevOps, we will understand what is the DevOps in data science, what are the different tasks for data science development, how to deploy models in production, how to deploy machine learning models as services, how to run machine learning models as Docker containers, and how to use the services like Kubernetes to actually orchestrate your containers. All those things we will be learning in this particular section. We'd also be learning about how to use Jenkins so that you can automate your entire pipeline, so that one job will be executed. After the successful execution of that job, another job will be executed, so that you can link all those things together. Now this will complete our 3 months curriculum. So a full holistic curriculum which will give a length, breadth and width of your data science understanding. I would also talk about few projects. So I told that we will be covering 20 plus projects. So these projects will go hand in hand with the course. It is not like a separate thing. After I do the course, you will do those projects. These are going hand in hand with the course, so that as and when we are learning about a specific topic, you would be doing that with a project. So when you do with a project oriented learning, then you would get a good understanding of how the data processing is done, how the model is applied, how your results are interpreted. All those things you will learn as and when we are doing the course. So I'll quickly go through the few projects. First, you will do some basic projects with Python, build an XML to CSV converter using Python, building a photo editor from scratch using Flask and Numpy. This will create a photo editor and where you can upload photos, do transformations of the photos and so on. And exploratory data analysis on retail shop sale data, fruit prediction using k-nearest neighbors, predict malignancy in mammographic masses using decision tree classifiers, predict whether a candidate is shortlisted in H-1B visa processing using random forest algorithm, predict breast cancer using support vector machine algorithm, HR analytics for attrition prediction using logistic regression, churn analytics in telecommunication, predicting house prices using linear regression, social network ad predictions, and retail customer segmentation using spending patterns, market basket analysis using a priori algorithm, SMS spam detection using natural language processing, sentiment analysis using restaurant reviews, using natural language processing and supervised machine learning, image classifications using deep learning, content-based recommender systems using deep learning, creating chatbots using recurrent neural networks and deep learning, stock market predictions using deep learning, exploratory data analysis of crime data using Boston. So these are some of the projects I have used a rapid fire kind of reading of the names. But what we will be doing is we will be going through every individual topic. So for example, SMS spam detection, this is used while we are learning natural language processing. We will see how to combine natural language processing and machine learning to detect spam SMSs. So there will be a lot of spam SMSs, so we will use how to detect the spam SMSs using this. Similarly, you could also do house price predictions, you could also do HR analytics. So we would like to identify who is going to leave the company. Now, depending upon different parameters available in the HR department, we are trying to identify who is going to leave the company and all those things. So for that, you would do this analysis. Breast cancer prediction using support vector machine and other things. So likewise, we will be doing throughout the exercise, we will be doing these projects, so that while we are doing the projects, we will be learning about those things. Got it? Any questions on the entire curriculum or the projects or anything of that sort? You can feel free to ask any questions.
Hello, Sitaram Garu. My name is Gayatri.
Yeah, Gayatri.
I have 15 years experience in IT. I'm holding bachelor's in mathematics and a master's in computer science. Right now, I'm working as a technical designer in Java related applications. So I'm looking for, adding some certification to my profile. Right now I'm not looking for the career change, but I know artificial intelligence is the next big thing. I'm looking for, after this course, can I prepare or can I, give any certifications?
Yeah. So there are different certifications which are provided by different companies. In fact, IBM provides. So there are basic level certifications like IBM, TCS, and a couple of companies provide. base level certifications, and advanced certifications are provided by some of the cloud providers. AWS provides it, Google provides it, and Azure provides it. So what you could do is, once you could complete the course, you will be able to crack those certifications easily. But if you are tuned towards some of the cloud providers, say like AWS, then there is AWS machine learning specialty certification. That would give you a very strong foundation. But if you want to get a certification like a data scientist practitioner or data scientist basic certification, then you could go for some of the basic certifications, like IBM gives that, TCS gives that, and other companies give it.
And yesterday you talked about API creation, right, to integrate the application with algorithms. So are you going to cover that API creation as well in the course?
Yes. So we will learn about Flask, and we'll learn about Docker, which will help us to create those APIs and deploy the APIs. So these projects we will be deploying, some of the projects we'll be deploying as APIs, so that those can be invoked by front-end services, and front-end service will invoke the API, and it will internally invoke the model, and you will respond back with output. So we'll see like how that could be done. We will learn Flask for that, and we will also learn Docker, how to link all these things with Docker. Those things will be learned.
And what are the job opportunities for data scientists in using Python in USA? Are there any companies using it?
I can't talk about one particular area, but definitely there are a lot of opportunities with different experience levels. If you are at a senior experience level, you should target about senior data scientist or data architect, or there are head positions leading a data science team and so on. So there are those kind of positions are some things which you should focus about. But somebody who is in the earlier phases or a few years of experience, for them there are other positions like data analyst, machine learning engineer, junior data scientist. Likewise, there are different positions for those kind of experience levels.
Thank you.
Any other questions?
So currently, right, I told you, right, I'm on Java, and I'm in technical lead in a Java technologies, right? So I'm just wondering, I know I'll prepare for it and I'll get some certification. How it's going to useful for my career? I can move it, shift easily. Or I'm just thinking, just getting this training, how it's going to be useful.
So to answer your question straightforward, nothing is easy. So definitely there is some learning is required, some struggle is required, but more than that, you need a lot of planning. You need to see like, where you are currently standing, what is your target, and what are the current open positions available within your vicinity. So you might be in US specific area, you might be in the eastern side or western side or any area, but in those areas, what are the job opportunities and what companies are focusing for that jobs, and within that, what are the companies targeting about? Are they banking companies, are they retail companies, are they startup companies? So depending upon those things, you have to identify which areas you need to focus, and then act accordingly. Definitely, I've seen many people doing internal switches and switching across the companies, but this study is required. Only then you can put a real good step. And for all these things, definitely there should be a preparation. You should know what is required, what is not required, and this course would help you connecting all the dots, certainly. And beyond that, it's personal effort, and a small pinch of luck also should be there. So all those things coming together, definitely this it will help.
Thank you, Sitaram Garu. Thank you so much.
And in my course, there will be different set of people, people who are just joining, who are completed their masters, few years of experience, working in India, working in US or other parts of the world. So this will be a mixed set of group. So as a course etiquette, what I would generally say is try to ask questions which are related to the topic. So I am not restricting people not to ask questions, but we will generally follow some etiquette as and when we go through the course. We will see like using of the chat. That would be an easier mechanism because it will not hamper any of the flow of the course, and also give other people a due chance of asking questions so that everybody get a sense of contribution that I also got my chance to ask questions. So likewise, as and when I go slowly into the course, once we have the batch finalized, I will talk about these some few important steps. So those could be used so that it will not hamper the entire aura of the course, or uh, basically the structure of the course.
And one more thing, do we get the environment to do the lab with the course during the course time?
We will be using something called as Google Collab, which is a Google Cloud provided environment. And for that, you just need to have a Gmail ID. You don't have to have a very high-end computer. If you have a simple Gmail ID, you will be able to work with all the experiments and codes and projects which we do.
Thank you.
So Windows 7 operating system doesn't matter. You can use it in any operating system. If you have a Gmail ID and internet connectivity, you will be able to use the environment. That I will talk in coming after few sessions, because we will be covering mathematics and basic statistics. Those are some theoretical topics. After that, we will get into the installation part. Till then, you don't have to worry about anything. So generally, my sessions, I'm taking this course for a very long time. So I have designed in such a way that we will have 45 to 50 minutes of a session. And then after that, we will give like 5 to 10 minutes, 5 minutes or 10 minutes for any questions. So continuously, we'll be having some 50 minutes of session. And after that, we will spend some few minutes for any sessions, any questions. Because I have batches one after the other. So I have a 6 to 7, 7 to 8, 8 to 9, like that. So if it overlaps, right, the questions are more and all. If it overlaps, what I will recommend is we will talk tomorrow, or maybe get in touch with me personally, and I can solve any of the questions you have, so that it will not hamper other batches schedule, right? So that's how I have divided. So we have 45 minutes to 50 minutes session. Then we will have few minutes for questions, so that we can clarify the questions then and there, and then we will go to the next session. That's how it is planned. All right. So I hope you got a good understanding of what we are going to cover, and what we are going to target for the next few months. I'm very sure that this would be a very meaningful session which you take, and definitely I'll ensure my level best to get you the best of the best knowledge, right? So that's how. So I'm getting a few questions. Management graduate of 18 years experience in finance. I want to switch over my career to data science. So will this help me? Yes, certainly it would help you. You have to identify the tools and techniques which are used in the finance industry. What you have to do is you have to mold your experience of using the data analytical related tools, statistical related tools, and you can mold your experience in such a way. You don't have to change everything else. You could say that I have experience in so and so finance, but over the years I've started doing some work in the data science in the finance industry. So your target would be the finance domain because you already have that experience. Your target would be the finance domain itself, but application of data science in the finance domain. So that is the focus area. Identify projects, identify customers who are working in that area. There are a lot of fintech companies which are also working in this space. So your target should be that, and definitely it is doable. We will be covering a lot of examples of how finance and insurance related things are used. So that should help you get into the details. Right. So my son is admitted to Georgia Tech. Congratulations, Ramakrishna Garu, for that. This really good college. And so while we're doing the mathematics and statistics, those are on the theoretical level. So while those things are done, he can go around with some of the Python related topics. So Python related topics would be talking about the basics of Python, like how to create the language concepts. So if he is able to go through those basic concepts, definitely he will be able to pick up. And we will definitely spend few months. So if he has some questions or anything related to any topic, I will be happy to help him out for understanding or giving some additional materials, video contents and other things. So that should not be a problem. All right, so I hope that you're getting some valuable information. So tomorrow we'll come back and understand about different industry areas which are using data science, and we will get a perspective of how different applications are used, and all those things we will be covering in the next few sessions. So these all fall under the first module, module 1, where we are understanding the basics of data science. So that is what we are covering right now. So in coming few sessions, we will cover those details, and then we'll slowly get into the other topics. I will go a little slow in the first week because people will be hopping in and hopping off, and they might not attend the first session. They might get confused for the third session and fourth session. So there will be a slight overlap and there will be a slight repetition. Please bear with me. But as and when we get the batch finalized, we will pick up the speed and go to the other topics. All right. Till then, take care and have a nice day. If you are in India and other parts of the world, please stay safe. Things are not really good outside. Do take care of your health, and we will meet tomorrow. Bye-bye.